Hello everybody. Today's presentation covers the new features introduced in Release 20.2 related to CBRS operation. This release supports 4 new features. The first one is the support of multiple grants. The second one is the reuse of remaining grants in case one or more grants are either terminated or suspended. The third one is the use of an alternate channel or looking for an alternate channel in case all the grants are terminated. And the fourth one is PAL support. We are going to now look at each one of these features one by one. Let's first review the current behavior. Currently, before the release of 20.2, all Cambium devices only hold one grant, regardless of the channel bandwidth that they're configured with. So if the device is configured with one 10 MHz channel, the device holds one grant, which is 10 MHz wide. If the device is configured for a 20 MHz channel, it's still only one grant, and the grant is 20 MHz wide, and the same for a 30 or 40 MHz channel. It's always just one grant, as wide as the channel that is configured. Let's now see what the effect is of having just one single grant in the device when a grant is terminated or suspended. Let's start with the grant termination case. The most typical scenario is a device that's operating on a channel as a GAA device, but somebody else won the PAL license on one of the channels this device is using. And at one point, when the PALs are going to be protected by the SAS vendors, the grant is terminated to allow the owner of the PAL to use their own channel. All the PALs are given in 10 MHz licenses. So 10 MHz can be terminated at a time, and it's possible that multiple 10 MHz channels are terminated, or it could be just one 10 MHz channel. Let's consider the case where a GAA device has one grant covering the 10 MHz, and this happens to be somebody else's PAL. And when the PAL is protected, now this grant needs to be terminated. Clearly, in this case, because the grant was only spanning the 10 MHz, the grant is terminated, there is no remaining grants, and no spectrum available. Assume now the device is again operating as a GAA device. It has one grant that covers 20 MHz. Now 10 of the 20 MHz is terminated by the SAS, but because the device only holds one grant, the entire grant is terminated. The SAS doesn't have the capability of telling the device that the first portion of the channel is terminated, but the second isn't. Because it's only one grant, the entire grant is terminated, and there are no remaining grants, even if half of the spectrum could have been used if only one of the two channels was claimed by the PAL owner. Similarly, if the device holds a 30 or a 40 MHz grant, even if only 10 MHz are claimed by the PAL owner, and there would be spectrum available, because the device holds only one single grant, the grant is terminated and there are no remaining grants in the device. Before Release 20.2, the solution to this problem is for the user to manually change the frequency or the channel bandwidth in the access point to try to reuse the remaining available spectrum. A similar scenario happens when a grant is suspended instead of being terminated. The most common scenario for a grant to be suspended is if a DPA activates on a specific channel. Again, the DPA can activate on multiple channels, but the granularity is 10 MHz, so it's possible that it only activates on one 10 MHz channel. If the device holds one 10 MHz grant, then the one grant would be suspended, and the device will be off the air, heartbeating the suspended grant until the grant is reauthorized. Let's consider the case where the device has a wider grant, either 20, 30, or 40 MHz. Assume only one of the multiple channels is suspended because of DPA, but the other channels could be available for operation. Because the device only holds one grant, the one grant is suspended. There are no other grants to use, which means again that the device is off the air. It is hard beating the suspended grant until the grant is reauthorized. In this scenario, the operator has two options. The first option is just to wait in suspended state until the grant is reauthorized. Because every few minutes the device is sending a heartbeat request, and the heartbeat response, it will know when the DPA has deactivated and the grant is authorized again, and at that point the device can start operation again. Another option is to temporarily select another frequency or channel bandwidth. However, be very careful with this solution, especially if you are in a CPAS area. If you change anything or try to move to another channel, you may have to wait for CPAS to be authorized. While typically the DPA event only lasts a few hours, the calculation for CPAS happens overnight. So the outage may be shorter, just waiting for the DPA to deactivate. Also, if you change anything in the configuration, like the channel bandwidth or the frequency, and try to use another channel, because the device only holds one grant, it does not have information on when the original grant is authorized again. So you would need to manually change it back to what the configuration was before to see if the grant is still suspended because the DPA is still activated, or if it is now authorized and you can operate on the original channel. The first change introduced in Release 20.2 is the support for multiple grants. The difference here is that when a device is configured for a wider channel, instead of holding one single grant, it holds multiple grants where each grant spans 10 MHz. If the device is configured for a 10 MHz channel, clearly it's going to be just one 10 MHz grant. But if the device is configured for a 20 MHz channel, the device is going to ask for two separate 10 MHz grants, each one on each of the two 10 MHz channels. Similarly, if the device is configured for a 30 or 40 MHz channel, then it's going to ask for either 3 or 4 10 MHz grants, each on the individual 10 MHz channels. Note that this is just a different way of asking for grants between the device and the SAS. From the RF point of view, the behavior does not change. The device is still operating on a single wide channel, 20, 30, or 40 MHz wide. It does not support carrier aggregation. It's one wide channel. It's just the messaging between the device and the SAS is splitting up this channel into multiple grants, each on 10 MHz. What is the difference between having one single wide grant and having multiple grants? The multiple grants enable a different behavior when a grant is terminated or suspended. Let's start with the scenario where a grant is terminated and there are remaining grants in the device. Same example we saw before. This is a GAA device operating on a channel that at one point becomes somebody else's PAL channel, and it is enforced in terms of protection, so the SAS will terminate the grant. If the device only has one 10 MHz grant, and that is the channel that is claimed by the PAL, then clearly the device has this grant terminated and there are no remaining grants. But if the device is operating on a wider channel, 20, 30, or 40 MHz, and now it holds multiple grants, what happens when the PAL owner claims his channel is that the one grant on the PAL channel will be terminated, but other grants may remain in the device, and these other remaining grants may still be authorized. So in the case of the 20 MHz channel, assuming the first channel is terminated, now the second channel is still available and authorized, and the device can continue operation on that 10 MHz channel. Clearly, there is going to be a hit in throughput and capacity because the channel bandwidth now changes from 20 to 10, but compared to the previous behavior where the entire grant was terminated and there was an outage, at least in this scenario, the device has access to the remaining 10 MHz channel. Similarly, if the device is configured for 30 or 40 MHz and one of the grants is terminated, then there are either 2 or 3 remaining grants that are authorized in the device. Now the device can change the channel bandwidth to either 20 or 30 MHz and continue operation on the remaining channels. The access point, when this happens, updates its center frequency and channel bandwidth in order to reuse the remaining grants and sends a follow me message to all the subscribers in the sector. When the subscribers receive the message, they also switch their center frequency and channel bandwidth to the newly configured one and reattach over the air to the AP on the new channel. Let's look at more examples of grants being terminated and the behavior of the radio. In the previous slide, we saw a case where it was the first of multiple available channels that was terminated, but that may not always be the case. The terminated channel could be one of the middle channels, or multiple grants could be terminated. Let's assume, for example, that the device is configured with a 30 MHz channel, so it holds 3 grants. And the middle grant is the one that is terminated. There are 2 remaining channels, 2 remaining grants, but because they're not adjacent, the radio cannot transmit on both of them. So the radio is going to relinquish one of the 2 grants and continue operation on only one 10 MHz grant. Similarly, if the radio is configured for a 40 MHz channel and it holds 4 grants, assume now the second grant is the one that is terminated. The radio has now 3 channels available, but again, they're not adjacent, so they cannot all be used. In this scenario, the radio is going to use the 20 MHz remaining channel because it's wider, and is going to relinquish the single 10 MHz grant. If 2 grants are terminated, then depending if they are adjacent or not, and if the remaining channels are adjacent or not, then the device may or may not be able to use all the remaining grants. In this final example, out of the 4 grants, grants number 1 and 3 are terminated, and 2 and 4 are remaining, but because they are not adjacent, then the device can only use one of the 2 and is going to relinquish the other one and only operate on a 10 MHz grant. Being able to support multiple grants changes the behavior of the device, not only in the termination case, but also in the suspension case. Let's assume that a channel is suspended because the DPA activates. Now the device has multiple grants, so one or more grants could be suspended because the DPA activated, but there could be remaining grants that are still authorized. In this scenario, the device keeps heartbeating the suspended grants, and then it switches operation on the channels that are still authorized, on the grants that are still authorized, reducing the channel bandwidth and moving the center frequency. Because the device still heartbeats the suspended grant, it knows when the grant is authorized again, when the DPA deactivates, and at that point, it's going to switch back on reusing all the grants by changing again the center frequency and the channel bandwidth. Let's take a look at some examples. Assume a device only holds 1 grant on the 10 MHz channel, and that channel is the one that is suspended. Clearly, in this case, there is no difference from the current behavior, where the device just heartbeats the suspended grant and needs to wait until the grant is reauthorized. But let's see what happens if the device is configured with a wider channel, 20, 30, or 40 MHz. Now the device holds 2, 3, or 4 grants. Assume only the first grant is suspended and the remaining ones are still authorized. The device switches its center frequency and channel bandwidth to be able to use all the grants that are remaining. So in the 20 MHz case, it would use the remaining 10 MHz grant. In the 30 MHz case, it would use the remaining 20 MHz grants. And in the 40 MHz case, it would reuse the remaining 3 10 MHz grants, so on a 30 MHz channel. The access point updates its center frequency and channel bandwidth and sends a follow me message to all the subscribers in the sector, so the subscribers are also informed of the switch and they can reattach over the air. As soon as the heartbeat on the suspended grant comes back as authorized, then the access point changes again. It changes the center frequency and channel bandwidth, and it sends a follow me message to the subscribers in the sector, and all the subscribers switch back to operating on the full channel again. Like we saw for the termination case, also for the suspension case, it's possible that multiple grants are suspended, or that the grant that is suspended is not on the edge of the channel, is not the first one or the last one. So like we saw before, the radio needs to decide which grants can be used during this temporary state where some of the devices are suspended, and we need to reduce the channel bandwidth we can operate on. Let's look at some examples. The first one has a device operating on a 30 MHz channel, so with 3 grants, but it is the middle grant that is suspended. The device still has 2 authorized grants, the first and the third, but it cannot use both of them because they're not adjacent. So it will switch to using only one of the 3 channels, only 10 MHz grant, and it will keep heartbeating all the grants. So channel number 1 will be authorized and in use, for example. Channel number 2 is suspended and it is still heartbeating. And channel number 3 is authorized, the devices are beating it, but it's not using it. As soon as channel number 2 is authorized again, then all 3 being authorized can be used, and the device can switch back to using 30 MHz channel. Similarly, if the device is configured for 40 MHz, it's now holding 4 grants. Assume grant number 2 is the one that is suspended. There are 3 remaining authorized grants, but the grant on channel 1 is not usable because it's not adjacent to the other 2. So the device is going to continue operating on a 20 MHz bandwidth using grants 3 and 4, but it heartbeats all 4, authorized or suspended. And as soon as channel number 2 is authorized again, then it switches back to using all 4 on the 40 MHz channel. In the last case, again, the device holds 4 grants, and now grants number 1 and 3 are suspended. There are 2 remaining authorized grants, but because they're not adjacent, the device can only use one of the 2, for example, channel number 2, and channel number 4, even if it's authorized, is not used, but the device keeps heartbeating all 4 until grants 1 and 3 are authorized again. So far, we have looked at cases where a grant was terminated or suspended, but the device had some remaining grants. Now we'll take a look at what happens when the device has no grants remaining. Let's start with the termination case. Let's assume, for example, a device is configured with a 20 MHz channel, so it holds 2 grants on channels 3 and 4. Assume these 2 are somebody else's PAL, so at one point they are protected by the SAS and both of these grants are terminated. Now the device is left with no grants. The device is going to trigger what we call a channel hunting algorithm, where it is going to look for another channel to use. The device sends a spectrum inquiry request to the SAS, and it looks at which channels are available in the response. If there are 2 channels available that are adjacent, the device is going to send a grant request on those channels because the device was configured for a 20 MHz channel. It's going to look first for another 20 MHz channel if it's available and it's usable. If there is no 2 adjacent channels, so it's not possible to find a 20 MHz channel, then the device is going to look for a 10 MHz channel instead, and is going to send a grant request only on that one single 10 MHz channel. So it's possible that the channel bandwidth shrinks during this channel hunting algorithm if it's not possible to find another channel with the same bandwidth as the configured one. This algorithm is just an attempt to find a temporary channel to operate in order to avoid an outage. It's not necessarily the best channel to operate on, but it is a channel that maintains the link. If the user wants to select a different channel, then they can go into the CNMaestro tool and perform a spectrum inquiry from there, see which channels are available with what EIRP, and they can pick a different channel and then push the different channel into the device. This channel hunting mechanism is replacing the previous mechanism that was based on pre-configured alternate channels. In the previous mechanism, the operator could define up to 2 alternate channels to be used, but the operator would have a hard time knowing which channels are actually available at this moment in time in this location. So it's difficult to guess what channels to configure for these alternate channels. In Release 20.2, the alternate channels are gone, and now the device can look for a different channel on its own when it is left with no grants. In the case where the grants are all suspended, this channel hunting algorithm will not be triggered yet. That will be introduced in a future release, where the same idea happens both when all grants are terminated and also when all grants are suspended. One important thing to understand is that the number of grants that the device is going to request from the SAS doesn't depend only on the channel bandwidth, but also on the center frequency and how the requested channel is aligned compared to the raster of 15 channels in this band. Let's look at an example with a 10 MHz channel. If the 10 MHz channel falls exactly into one of these 15 channels that the SAS has visibility to, like from 1 to 15, then the device is going to ask for just one grant on one specific channel, in this case on channel 4. But if the device is configured so that half of the channel overlaps, in this example, channel 3, and the other half overlaps channel 4, the device is actually going to ask for 2 grants, one 5 MHz grant on that portion of channel 3 and another 5 MHz grant on the portion on channel 4. So the device operates on 2 grants even if the channel bandwidth is only 10 MHz. Let's look at another example with a 20 MHz channel. The 20 MHz channel can be perfectly aligned to 2 of the 15 channels in the band, or it could cover one full channel and 2 half channels, as shown in these 2 pictures. If it's perfectly aligned to the 2 channels, like in the bottom pictures, so these are channels 4 and 5, then the device is going to ask for 2 grants, one on channel 4 and one on channel 5. If the channel is aligned as shown in the top portion of this picture, then the device is going to ask for 3 grants, one for the 5 MHz in channel 3, one for a full channel 4, and one for a half megahertz that overlaps channel 5. So in this case, there are going to be 3 grants instead of 2, even if the channel bandwidth is configured as 20 MHz. What are the advantages and disadvantages of the 2 scenarios? Always remember that when a grant is terminated or suspended, it is on one 10 MHz channel in this raster shown here. So if the device is configured as in the bottom feature, then there are 2 chances that the channel is going to be suspended or terminated. But if it's configured as in the top picture here, then there are going to be 3 chances of something changing because channels 3, 4, or 5 could be impacted with a termination or a suspension. So in general, the alignment shown at the bottom is preferred because you have fewer possibility of being hit. And the other thing to consider is what's remaining. Let's assume that in the bottom picture, channel 4 is the one that's terminated or suspended. Now you have the opportunity of operating on channel 5. But if both 4 and 5 are terminated or suspended, then you don't have any remaining grants. In the top portion, if 4 and 5 are terminated or suspended, now the device is going to switch operation to just the 5 MHz that are left in channel 3. So if you align the channel as in the top picture, it's more likely that you're going to have something left, even if it's only the 5 MHz channel. But overall, the risk of being hit being higher in the top configuration versus the bottom configuration It's still better if you align the channel to this raster shown at the bottom so that the channel is fully inside one of these 10 MHz slices, and either the grant is fully authorized or it's fully suspended or terminated. This minimizes the impact and the number of changes in your network. Here is one more example with a 15 MHz channel. Because the channel has to be aligned to the 5 MHz raster, the 50 MHz channel doesn't have good or bad cases. Both the 5 plus 10 or the 10 plus 5 are acceptable. In both cases, there is going to be two grants, a 10 MHz grant and a 5 MHz grant. And then depending on which channel is affected, if there is a termination or a suspension case, then the device is left either with a 5 or a 10 MHz channel. Because you don't know in advance which channels are affected, then both these two configurations are acceptable. In the previous slides, we covered the cases where an operator needs to select a new channel, and the recommendation is to make sure it is properly aligned to the 10 MHz raster. But what if an operator is converting an existing grant, and that grant is not properly aligned? In this case, there are two options. You can either keep the same center frequency, or you can try to realign it to the 10 MHz raster. Let's look at one specific example. Let's assume you have a 20 MHz grant, a single wide grant, that covers a portion of channel 3, whole channel 4, and a portion of channel 5. You relinquish this grant, and the radio automatically asks for the same channel with the same center frequency. Now, the radio is going to hold three grants. One grant on the 5 MHz of channel 3, one grant on the whole channel 4, and one grant on half of the channel 5, the 5 MHz on channel 5. These three grants will be immediately authorized if you are connected to Google, Federated, or CommScope in a non-CPaaS area. So in most cases, the grants will be authorized right away because this was exactly the channel you had before. The problem is that now you're not properly aligned to the 10 MHz raster. So in this case, you have three chances of one of the channels being either suspended or terminated. The other option is to readjust the center frequency so that now you're fully occupying only two channels, channel 4 and channel 5. If you do that, then the slice of 5 MHz in channel 3 is going to be relinquished. The grant on channel 4 is going to be authorized immediately because it overlapped the channel you had before. And now the grant on channel 5 is subject to the rules of any new grant. Note that in many cases, the SaaS vendors do give a grant, an authorized grant right away on the same day, potentially with a lower EAIP, but in many cases it will be authorized. However, there are some cases in CPaaS areas where it may be suspended and you have to wait until CPaaS to be fully authorized. So the risk in this second scenario is that you will operate only with the 10 MHz channel on day one, and then after CPaaS the next day, you can operate fully on the 20 MHz channel. If you decide to do this and you are in a CPaaS area, then it may make sense to make this change as close as possible to CPaaS time to try and limit any disruption. But the advantage is that now you are perfectly aligned to the 10 MHz boundaries, and now you only have two possibilities and not three of having one of your grants either suspended or terminated. Another recommendation is to check the list of center frequencies and channel bandwidth configured in the SM. In this release, the AP could change its center frequency and bandwidth on its own in case one or more grants are terminated or suspended. When that happens, obviously the SM needs to follow the AP on the new channel and reattach over the air. In most cases, this is taken care of by the follow me message, meaning that when the AP changes either the center frequency or the channel bandwidth or both, it will send a message to all the SMs indicating the new parameters, so the SMs can update the parameters and reattach immediately on the new channel. However, there are some cases where the SM may not receive the message, for example, if the SM is turned off. When the SM is turned on again, it will first look for the AP on the original channel, But because it doesn't find it, then it needs to scan from scratch, going through the list of all possible center frequencies and channel bandwidth that were selected at DSM. Because the AP could be now on any channel and potentially different channel bandwidths, it's important that all of them are selected, and the center frequencies are selected on a 2.5 MHz raster, because this covers all the options, and DSM will find the AP for sure. The 450 SMs should already have the frequencies configured on the 2.5 MHz raster, but the 450B and 450I were on a 5 MHz raster because they cover a wider band. So make sure you have all the values in there, and if you want to just push a template to all your SMs to make sure they all have the right raster, you can follow this link and find the template, or you can contact Cambium and we can help you with that. One consideration to take into account when changing channel bandwidth is that the bandwidth is one of the parameters that affects the frame structure, meaning the timing dedicated to the downlink and the uplink portion of the frame. When the radio automatically changes channel bandwidth, now the frame timing is going to slightly be updated, and this could potentially, in some cases, create some overlap between the current downlink and uplink times and the previous downlink and uplink times. If this device is isolated, this is not a problem. But if the same configuration is used by multiple sectors in the same area and only one sector updates the channel bandwidth, so now its frame is slightly different, it's important to double check that there is no overlap between one downlink and another uplink, so that collocation is still possible. Let's look at an example. Let's assume the device is configured with a 2.5 millisecond frame, 1 mile range, 4 contention slots, 70% duty cycle, and we begin with a 40 MHz channel. In the plot here, the top portion shows the downlink time in blue and the uplink time in green. Now, if we keep everything the same and we just switch the channel bandwidth from 40 to 10, the second frame structure shows the new downlink and uplink time. So we can see that the downlink is shorter than before and the uplink is longer. Now, just making this change, there is a slight overlap between the previous downlink and the new uplink. So if there are other devices in the area that use the same configuration, the original one with the 40 MHz, and now this one device switches to 10 MHz, there could be potential self-interference. The easier way to fix this is to adjust the duty cycle. Other parameters could also be adjusted, like the max range or the number of contention symbols, but the duty cycle is the most straightforward. In this example, if we change the duty cycle from 75% to 77%, now the second frame moves slightly, so the downlink is a little longer, and we remove that overlap between the previous downlink and the new uplink. When the device changes channel bandwidth on its own, there is going to be a message appearing reminding the user to double check this scenario by using the collocation tool. But if the user changes the bandwidth manually on the device, this message does not appear, as it is expected that the user has already checked that collocation is possible with the new parameters. Release 20.2 introduces several new features, and some of these can be manually disabled from the AP GUI if you decide to do so. There are two configuration options we want to discuss here. The first one applies to all the access points, and the second one only to the 450M access point. The first one is a configuration option to allow the device to search for alternate channels when no grants remain. This is the case where the device holds one or more grants and all of them are terminated. Because there are no remaining grants to use, the device is going to trigger what we call the channel hunting algorithm to go look for another channel to use. If you do not want the device to trigger this algorithm and look for another channel, then you can disable this feature in the GUI, but the feature itself is enabled by default. The second option that you can disable is to allow or not allow the 450M AP to reboot if the channel bandwidth needs to be adjusted. This applies both to the termination and the suspension case. This is the scenario where a device has multiple grants and one or more are terminated or suspended, but there are some remaining grants. The device is then going to try to reuse the grants that are still authorized, which means it needs to switch the channel bandwidth to a smaller value. For all access points except the 450M AP, this is not a problem because the channel bandwidth can be changed on the fly without a reboot. But in the 450M AP, changing the channel bandwidth requires a reboot. If you do not want to reboot the AP automatically, then you can disable this feature, which is enabled by default. What happens if you disable these two features in the AP GUI? In the termination case, the device just stops operating and waits for the user to select another channel. In the case where there are no remaining grants, if you disable that option, then the device is not going to look for another channel. And if in the 450M case, if you disable the option of rebooting because the channel bandwidth change is required, now that is not allowed so that the device cannot switch bandwidth. It means it cannot reuse the remaining grants. So in these cases, the device is just going to stop operating and the user needs to manually pick a different bandwidth or a different frequency. In the suspension case, which only applies for the 450M, if you don't allow the reboot, then what happens is that the device keeps heartbeating all the grants, the suspended and the authorized ones, until they're all authorized again, but they will not use the remaining grants during the time the DPA is activated and one or more grants are suspended. The last major feature introduced by Release 20.2 is the pulse support. This is truly a byproduct of all the other features we have already discussed. The fact that the device can support multiple grants, that it can either reuse remaining grants or looking for new channels in case a grant is terminated or suspended, they all play a role into supporting Pulse. With Pulse, the main example, the main case, is the grants being terminated because somebody else won a PAL license on that channel, and now the SAS is protecting that device. PAL support from all the SAS vendors is expected to be enforced on April 15. What do you need to do before this date? If you want a PAL license, if you're a PAL license holder, then the first step is to enter or verify your FRN in your SAS vendors portal. Contact your SAS vendor for any indication that you need, for any help for how to do this. Verify the PAL channels assigned to you in the PAL channel assignment portal. This is going to be available only later in April, a few days before this date when all the SASs are going to start to enforce PALs. For the CommScope customers only, you need to go into the portal and you need to add devices to PAL protection areas. Essentially, you need to explicitly identify which device you want to be part of each PAL channel, of each PAL protection area. Contact CommScope directly if you need more information on how to do this step. For all the customers, the Cambium customers, regardless if you have a PAL or a GAA, you have to upgrade your APs and your SMs to Release 20.2, and you have to upgrade the CM Maestro to Release 3.0.2 if you're using on-premises. The reason is that you also need an upgrade to CM Maestro to be able to handle the multiple grants, the same way that Release 20.2 allows the device to handle the multiple grants. Also, check which channels in your county have been assigned to another operator's PAL license. So in each county, there can be up to 7 PALs. Some could be yours, some could be somebody else's. You need to understand how many channels are available and how many channels remain GAA, and which ones are your PALs, which ones are somebody else's PAL, so that you know which channels you can use. After you have upgraded the software, the next step is to convert the grants. All devices hold just one grant up to now, but with Release 20.2, they will be able to convert the one single wide grant to multiple grants on the same channel. This clearly only applies if the device is operating on a channel bandwidth greater than 10 MHz. When you do that, when you relinquish the grant and ask for the same channel again, the behavior from the SAS is not the same across all the SAS vendors. If you are operating with CommScope, they consider the grant as relinquished and there is no memory of what the grant was. Even if you ask for the same channel right away, you still have to go through all the calculations as if this was a new grant. So if you are in a CPaaS area, you may risk of having a grant suspended until CPaaS or potentially having a lower EIRP until CPaaS. So we recommend that you do the grant conversion as close to CPaaS as possible to minimize the chances of disruption. With Federated Wireless and Google, there is a feature where they can detect that the request is on the same channel that you just relinquished. Essentially, there is still a reservation for your grant, even if you relinquished it, but now you're asking for it again, even if it's now multiple channels instead of just one wide grant. And because they recognize it's the same channel, they're going to authorize the grant right away, even if the first time you had to wait for CPaaS. Federated Wireless already supports this feature, and Google is going to support it by the end of March, so before you're going to convert your grants. Now, if you are a PAL owner and you won a PAL license on a specific channel, then your next step is going to move your frequency to the channel that was assigned to you. Assume, for example, you're operating today on channel 3, but your PAL channel is going to be channel 5. You can either change your frequencies before or after launch date. Both are acceptable. If you decide to move the device from channel 3 to channel 5 ahead of launch date, then the device is going to be considered as GAA, meaning it's not protected until launch date. Only after the launch date, then the device is going to be fully protected. What happens when you add a device to a PAL channel? If this is the first device, let's say, for example, this is after launch date, and this is the first device you're moving to channel 5, then the protection is going to happen only overnight during CPaaS when all the calculations are done. The PAL protection area, the PPA, is going to be calculated and the contour is going to be defined so that now your device is fully protected. So on day 1, it may not be fully protected. After CPaaS, it's going to be fully protected. Now, assume you have already added some devices in the area on that particular channel so that a PAL protection area is already defined. Here in this picture, there's an example where we have 4 devices, the 4 blue dots. These are already operating as PAL devices on this channel and are fully protected. And here the PAL protection contour is shown. Now I'm adding a 5th device. If the device is inside the PAL protection area, then it is fully protected on day 1 because this area is already protected. But if the device is outside the protection area, then on day 1 it's not fully protected. Then overnight during CPaaS, when the SAS runs all the calculations, the PAL protection area is going to be adjusted, is going to be increased. The contour is redrawn, and now the device is fully protected. So if you are the owner of the PAL license and you're moving your devices to the PAL channel, then there are these considerations to think about. Do I want to move before launch date or after launch date? Of course, if you have with CommScope, don't forget you need to define your PPAs in their portal. So contact CommScope to be able to do that. If you are not a PAL holder, or you are, but there are other PAL owners in the same county as you're deploying, so that you may have to move some of your GAA devices out of some channels, you may need to reshuffle the channels, meaning redo your frequency planning, because some channels may become unavailable. Other channels is the ones that you want to use because these are your PALs. So when the PALs are enforced, a lot of operators are going to redo the frequency plan to understand which channels are available and take advantage of that. In some counties where there may be congestion, this may not be very easy to do, and the SAS vendors have offered some support for frequency planning in these congested counties. So if you have questions, you can reach out to your SAS vendor and see if they can give you some help or guidance with your frequency selection. Assume now this is after the launch date when all the SAS vendors support the PAL protection, and you're asking for a grant request for a device on your PAL channel in your county. The question we asked all the SAS vendors was, by what time do you need to send this grant request to make sure that the PAL is fully protected after CPAS? Essentially, you want to make sure that you send the grant early enough so that you don't miss the window when the calculations happen. This is the answers we received from each of the SAS vendors. For Federated Wireless, they said you need to submit your grant before midnight Eastern Time. For the Google SAS, it is before 11 p.m. PST. For CommScope, it's slightly different because, like we mentioned, you need to enter the information in their portal. The calculations on the contour will begin as soon as the devices are associated to a PAL. So you go into their portal, you indicate which devices you want on each PAL channel, and the calculations are going to start right away. Of course, the CommScope SAS needs to exchange that information with the other SASs at CPAS. And that CPAS time when all the SASs exchange information starts at 7 GMT. So only at that point, the CommScope SAS is going to be able to send the pre-calculated contours to the other SASs. The grants for the PAL devices for the PPA can be requested after CPAS, and now they will receive immediate protection because the protection was already exchanged across all the SASs during that one CPAS. Or the other option is that the device can ask for a grant before CPAS. It will be authorized but not fully protected until CPAS. The important thing is that you define the PPA, so you go in your portal and associate the devices to the PAL channel before CPAS happens. As we already discussed, it is recommended that you upgrade to release 20.2 before the date the PALs are enforced, because you want to take advantage of the capability of the radio to support multiple grants. This is true both if you are the PAL winner and want to use your PAL licenses, or if you are continuing operating your devices in GAA channels. In both scenarios, there are advantages in upgrading to 20.2 because of the multiple grants feature. If you are operating as a GAA device, that's what we already discussed. It's possible that one of the channels are going to be claimed by somebody else's PAL, and now the grant will be terminated. But if you have other remaining grants, then you can take advantage of that. So that's an obvious advantage for the GAA users to upgrade before the date the PALs are enforced, because you may lose some of the channels you're operating on, but you may be able to reuse some of the existing grants. There are also some scenarios where it's the PAL user that really needs to take advantage of the multiple grants, because there are some situations where without the multiple grants, things just don't work. The grant will not be accepted by the SAS. There are two cases. The first case, which is potentially a problem with all the SAS vendors if you don't upgrade to 20.2, is a scenario where an operator has won a PAL license in a county but wants to operate with a wider channel. So the 1 megahertz is the PAL channel, but they want to operate with 20, 30, or 40 megahertz. So they want to augment the PAL channel with the GAA channels. If you send a single grant request to any of the SAS vendors for example, a 20 megahertz channel where 10 megahertz is your PAL and the other 10 megahertz is a GAA channel, the SAS will not accept this request. It will be denied. The only way to do this is to send two separate grant requests. One grant request on the 10 megahertz PAL channel and another grant request on the 10 megahertz GAA channel. At this point, both grants are accepted and you can operate on the 20 megahertz channel. This is what the radio automatically does in release 20.2. So there is nothing you have to do except upgrade the device to 20.2. There is another situation that only applies to the CommScope customers. Assume an operator has won multiple PALs in the same county, and they want to operate with a 20 MHz channel where both 10 MHz slices are their own PAL channels. With the CommScope SAS, if you send one single grant request on the 20 MHz channel, the request will not be authorized. You need to send one grant request on a 10 MHz channel, your PAL, and a separate grant request on the second PAL channel. At that point, both grants will be authorized, and you can operate on the 20 MHz channel. So these are some examples where you really need the support of the multiple grants, also if you're planning on operating with your PAL channel, not just if you're planning on operating as a GA device.